This is a super fun lab, and I wish you guys could be here to do it, but unfortunately we don't have that ability to do so. So I'm going to do a walkthrough. It's going to be 3 parts. This is the first part, and we're going to go through the setup and the background, and then there's going to be a video on me doing the lab, and then we'll come back and we're going to do a conclusion as well. So let's go ahead and I want you guys to read along with me and highlight, underline a couple things, and we're going to be changing a couple things within this as well and reviewing what we previously done in this electrochemistry. So we're going to read this first paragraph right here, and so if you can kind of follow along. If you ever turn on a flashlight, awaken to a traveling alarm clock, listen to a boombox, or used any electrical device that runs without being plugged in, you have used a battery. A battery used as a source of electrical energy is usually a combination of chemical cells. If you remember the voltaic cell, a chemical cell can also be referred to as a voltaic cell. It uses a chemical reaction to produce an electrical current. If you remember, it throws the electrons, and therefore we have the flow of electrons, which is the definition of electricity. In a chemical cell, one substance loses the electrons to another substance that gains them. Remember, we got the pitcher and we have the catcher. We have the oxidation, we have the reduction. The loss of electrons will produce positive ions, remember the zinc, for example, and the gain of electrons will produce negative ions. This flow of electrons between substances is called an electric current. The first person to observe that a chemical reaction could produce an electric current was Volta in the 1790s. The volt or voltaic cell are named in his honor. So here, what we're going to be doing in this lab, instead of using zinc, we're going to be using magnesium. So I want to use the same format that we've been using previously. We're going to be having 2 different sides, or 2 half reactions, or 2 half cells to show these reactions taking place. So on the left-hand side, as we've done in previous lectures, we're going to have the oxidation reaction. If you remember, in an oxidation reaction, this is the reaction that happens first. It's called a redox reaction, but the oxidation takes place first. So remember, pitcher and catcher. The pitcher is the oxidation reaction. So we're going to lose an electron. The pitcher loses or throws the electron. This is the source of the negatives. So this is the negative terminal, or the negative electrode, and this is going to be called the anode. So on the other side, we're producing this electron, and this is going to be the reduction reaction. It's the opposite of losing, so it's going to be gaining the electrons. The electrons are being attracted towards the positive end, and like positive ions are called cations, this is going to be called the cathode. So we're going to be starting off with magnesium. Magnesium is going to be neutral, and it's going to be this nice silvery strip of magnesium. And what it's going to do is it's going to produce the 2 electrons. If you could put a little negative here. So it's the 2 electrons. Since it's losing 2 negatives, the magnesium becomes 2 plus. When the neutral magnesium becomes charged, it becomes an ion. It's no longer in the solid form, but it's going to dissolve. That's what's going to be going into the liquid. So then, this is a little strange right here, a little bit of a mishap with this right here. Over on the other side, the copper is sitting, so we can cross this off right here. And we also have the 2 electrons. So the copper is sitting at the other electrode, and it's going to be accepting those 2 electrons. The copper is going to be a blue fluid, much like this blue fluid right here. It's going to be accepting those electrons, and it's going to turn it into copper. So I want to share again the goal of this, if you can use the space down below here. I did this demonstration where I had a tray, and it was filled with this blue stuff called copper sulfate. So the copper sulfate is sitting there, okay, and we're just going to say that it's going to be the copper in this ion form. This is the copper portion of the copper sulfate, because if you remember, when you put substances that are soluble into water, they're going to dissolve into their ions. So we have this copper ion that's sitting there. And if I put in this metal strip, as we did in the demonstration, this is the zinc strip, if I put that zinc directly into the copper, the zinc is higher on the activity chart compared to the copper, and so we get this drop down of the electrons. We get this immediate transfer of electrons. So the electrons get transferred to the copper. What we're trying to do in this voltaic cell is to separate the two things. So if you remember, we drew this in lecture. We have a half cell over here. We have the other half cell over here. What we have is we have the zinc plate on this side in the zinc sulfate, and we have the copper plate with the copper ion. And the goal of this is to get this transfer of the electrons from this plate over here to this plate over here. And then we can sort of catch them or use them as they're traveling through in process from one side to the other. That's what also takes place inside of a battery. You have the loss of electrons on one end of the battery, then it flows through your device, the electrons flow through your device, then it goes to the other end of the battery, and that's where the electrons go. So again, we still have the pitcher and the catcher, but instead of them being side by side, we're sort of catching the ball in between, using its energy, and then delivering it to the catcher on the other end. So going on to the next page, here is our setup, and here is going to be our battery. Instead of zinc, we're going to be using magnesium. So here is our magnesium strip that we had in the previous reaction. This is going to be our negative end over here. This is going to be the source of the electrons. Okay? We're going to have this fluid down below, and this fluid is going to be sodium sulfate. This is what this is going to be sitting in. What's going to happen is we're going to lose the electrons. The electrons will move from here into the liquid, and therefore the electrons are going to leave this. This is going to be attached to an alligator clip, and it's going to be attached to a small light and also a small motor. We're going to see if it's enough to power those things. But again, you just can't throw electrons out into the air. It has to go somewhere, and it's going to be on the other side over here. So here's the magnesium strip. On the other side, we've got the copper strip. So it's just like our previous setup. And inside, we have the copper sulfate. And the copper sulfate is sitting inside of this almost like a plastic baggie. It's called dialysis tubing, and I'll show the dialysis tubing when we go to the experimental portion of that. So the electrons are going to be going over to this side, and this is going to be our voltaic cell. Okay, so these are some of the things that we're going to be doing. I've already sanded and cleaned our copper and magnesium strips, and I'm going to take this dialysis tubing, I'm going to tie it in a knot, and I'm going to pour in the copper sulfate liquid into this. Then I'll put my copper, and I'll hang it over the edge right here. The sodium sulfate will be filled to this level here. Then the magnesium strip will be placed on the other side. I'll then insert this rubber stopper to hold everything in place, and then our battery is ready. It's just sitting there, ready to throw the electrons, but of course we have to complete that circuit. This sodium sulfate acts as a liquid which is going to accept the ions coming off the magnesium strip, but it's also our salt bridge that connects these two as well. So the electrons are not going to be flowing across the liquid, but the electrons are going to be flowing out in this direction right here, and we'll do that in the series of next two videos.